lesson. Today we're going to be taking a look at graphs of functions. Recall that we first learned about relations and what makes a relation a function. Then we learned some notation for functions, and that notation helped us to create mathematical models that were less confusing. Well, keep in mind, our data is always going to tell us a story, and a story, it's nice to have some pictures that go along with that story. And that's what graphs of functions are. There's just a nice visualization of what that data is telling us. But before we get going, as always, we're going to have a little bit of terminology. So today we're going to talk about our number sets before we get going. First of all, our number sets can be kind of viewed as this little Venn diagram here. Starting with the innermost set is our natural numbers. Now, our natural numbers are just our counting numbers. You would start counting at 1, 2, 3, 4, so on and so forth. Next up is our whole numbers, which are really just our natural or our counting numbers, including the number 0. So now we're going to start our counting at 0. Integers are next. Now our integers are both our positive and negative whole numbers. So you can see that includes our -4, -3, -2, 0, 1, 2, 3, so on and so forth. Next up are rational numbers. Now, hidden in that word rational is the word ratio. Rational numbers are simply those numbers that can be written as a ratio of two integers, such as 3/4. Now that condenses down to 0.75, or you could have 7/8 or -1/2. Those are all rational numbers. Okay, next up is irrational numbers, and simply put, those are numbers that can't be written as a ratio. Those are also known as never-ending decimals or non-terminating, non-repeating decimal values, such as the square root of 5 or the number pi, which you can see I'm wearing on my t-shirt today. Next up is all real numbers. Now, all real numbers encompass all of these types of numbers that we just talked about. And that's really what we're going to be looking at today is real functions. And so understanding real numbers and these little symbols here that go along with these different number sets are going to be used to shorten up the number sets that we're talking about. All right, some more important terminology for today. And this is really going to carry with us throughout the entire year. We're going to talk about the domains of functions and the ranges of functions. Now, the domain are simply the set of allowable values for the independent variable. They are our x values of our function. Our range are the set of allowable values for the dependent variable. In other words, they are going to be all the y values of our function. Now, there's a little visualization going on down here. You can see in our graph, we have a coordinate plane, x and y. Now remember, f of x is just a fancy way of saying y. These are our independent variables and our dependent variables. Okay? In other words, our input goes on the x-axis and our output goes on the y-axis. And you can see here's our little graph. It's got a nice little squiggly curve to it. And oops, it's not a straight line. Let me get that out of there. But it is this nice little curve, and the domain can be found as the interval along the x-axis of all those x values for that function. So a way to think about this is if you were to flatten that curve onto the x-axis, what interval of x values would be contained in that function? All right, another way to think about the range then is if we were to take that graph and flatten it along the y-axis. If we were to press this all against that y-axis, we would see that that range of values, or the set of allowable outputs for this function, would be in this interval here. Now, we'll get lots of practice with that throughout the course of the year. One way that we use, or one form of notation that we use to express our domain and our range is known as the set builder notation. And it has a specific format. It's got these little braces, okay? So the domain D, colon, an open brace, the x value, because the domain represents the x values, and then it gives the interval of the domain. The range is very similar. You have R with a colon, R for range, and then an open brace, Y, with this vertical slash here, and then the interval of that range, and then a closed brace. That's known as set builder notation. So we'll get some practice with that here in just a few minutes. All right. Again, here's our set builder notation. Let's get a little practice now using this function, which looks very similar to the picture that we saw just a few slides ago. We want to give the domain and the range for the graphed function by flattening the curve on each axis. So let's start off with our domain. We're going to say D : open brace. The brace looks like the face. X with a vertical slash. Now we're going to find that interval of our domain. So if we were to take this curve and flatten it on the x-axis, I would push all of these points up, and it looks like it would start here at -2, and I would push all of these points down, and it looks like here it would end at 3. So the domain of this function is in the interval between -2 and 3. And the way that we express that is we say our minimum value, which is less than or equal to our x value, and that's less than or equal to our maximum value. And then we close our brace. So this is set builder notation for our domain. Now let's talk about our range. We're going to say R : with an open face, open brace, Y vertical slash, and now let's just erase what we have here so we're not too confused. We're going to take a look at flattening this curve along the y-axis. Our y-axis here is the vertical axis, and if I push all of these points here to the left and all of these points here to the right, it looks like my interval is going to go from -1 to +1. So again, I'm going to start off with my minimum value, say that that's less than or equal to my y, and that is less than or equal to my maximum value, which was +1. And then we'll close it off with another brace. That looks like a face, but that doesn't look so good, so let's try that again. There we go. There is the set builder notation for our range. All right, in example 2, we're given a relation here, and we're asked to find the domain and the range for this relation. Well, remember, the domain is simply our x values. Now, this is not a continuous graph. This is what's going to be known as a discrete graph. It's just these plotted points, and you can see I graphed it down here. Now, you don't have to do that, but I wanted you to get the visualization because we are talking about graphs of functions. So how do we list this domain? We're going to start off the same way. We say D : open brace X with a vertical slash. Now, we're just going to actually list our points. So -3, -1, 2, 4, and 5. And then we're going to close that. Now, keep in mind, I'm only listing the x values because my domain represents my x values. All right, let's talk about our range. Okay, we'll start off with our R : open brace, Y vertical slash, and now let's list our range of values, or our y values. I have 1, 0, 6, 0, and 1. And what you'll notice is that there's a few repeated values. We actually don't need to list those values twice. We only need to list them once. So I'm going to list my 0, 1, 6, and that's it. And I will close that off. So those are my outputs, or my range of values. Is this relation a function? Explain how you know. So I'm going to say yes, this is a function because there are no repeated x values. And we can see that visualization here if we look at our points. And we think about that vertical line test. If we were to drop a vertical line through any one of these points, it wouldn't pass through a second point. So I can also say that it passes the vertical line test. All right, let's move into example 3. Again, we have some more graphs of functions here. So a little picture of what's going on. And we're asked to give the domain and the range using set builder notation. All right, so taking a look at graph A, my domain, we're getting pretty good at this now. D : open brace X with a vertical slash. And now I'm going to look at the interval. So think about flattening this curve on the x-axis. And I'm just going to write domain here by our x-axis to remind us that domain are x values and range are our y values. So flattening this down, it looks like it's going to start here at -1. That's my minimum value. Less than or equal to x, less than or equal to, and if I flatten everything down on that x-axis, it looks like I had to push that guy up to the x-axis, my maximum value will be 4. And there is my domain. Next up, let's talk about our range. And now again, I'm going to flatten everything on my y-axis. So it looks like my maximum point is going to be up here at 5, and my minimum point is going to be down here at -4. So I start off by listing my minimum less than or equal to y, which is less than or equal to my maximum, which was 5. All right, in this second example, we actually get a bit of a different case here. You'll notice that this graph continues from off of the screen here. It's kind of like an arrow being on it, and it goes off the screen. So how do we write domain and range for a continuous function that seems to keep growing in both directions? All right, let's talk about that. We're going to do it in set builder notation. So our domain here is going to be a set of all x's. If we were to flatten this on the x-axis, you would notice that this arrow is going to keep growing to the left, and this arrow is going to keep growing to the right. So really, it's going to contain all of my values along that x-axis. And so what we say there is that this is really just the set of all real numbers. So we're going to use that symbol for all real numbers, which basically just looks like a capital R with a second leg on it. So 2 legs and an R. So this is just the set of all real numbers. Now the same is actually going to be true for range. Our range of values here, if we were to flatten this on the y-axis, because this arrow is going to keep growing up and this arrow is going to keep growing down, it's going to contain all of these values along the y-axis. So we'll say that our range is also the set of all real numbers. For our final example for today, we're going to take a look at graphing a function using our graphing calculator. So take a second to pause the video and find your graphing calculator. You can see that I have mine pulled up here on the screen. So I'm going to lead you through how to enter this into your graphing calculator. Once you've turned it on, you are going to find the y equals, which is up in this top row of function buttons. You're going to press y equals, and now we're going to enter in our equation, which says parentheses x plus 3. So the x is right next to the alpha key, and that says xt, theta, and n. So go ahead and press x, and then we'll put our plus 3, and then we're going to close our parentheses. That quantity needs to be squared. So our squared is right over here along the left-hand side. You should see x squared. So go ahead and press squared. And now we're going to subtract 2 from that quantity. All right. First, we are asked to view the graph of this function. So along this top row of function keys, you should see the key that says graph. Go ahead and press graph. Now, this should take you to the standard viewing window. If your viewing window doesn't look the same as mine, then you can go to the zoom function and down to number 6, where it says zoom standard. Press enter on zoom standard, and now your graph should look the same as mine. Next up, we're asked to view the table of the function and find y when x is 9. So to get to the table, you should see table written in a different color right above the graph. In order to get that, you're going to press the second function button and then the graph. And here you can see our table of values. We can scroll down the x, or we can scroll up to get into our negative values. And we are asked to find the value of y when x is 9. So when x is 9, my y is 142. Next, we're asked to trace the function to estimate y when x is 1. So we're going to go back to the graph by pressing the graph function and then the trace function. Now you should see a little cursor placed on your graph. When we trace, we always move left and right with our left and right arrows. So you can see the coordinate that it starts me on is when x is 0 and y is 7. So I'm going to move to the left here to get close to -1. When x is equal to -1 or approximately -1, my y value looks like it's around 1.75. Finally, we're asked to give the domain and the range of the function. So I'm going to go back to just my graph here, and I can see it looks like my domain is going to be the set of all real numbers, because this is going to continue growing wider and wider as these arrows continue off the screen. My range, if I were to flatten this on the y-axis, looks like it's going to start here at about -2 and then continue to grow up. So I'm going to say it's the set of all real numbers greater than or equal to -2. Don't worry if this seems a little bit strange or difficult to you now. We're going to get lots more practice in class.